Hey guys, welcome to my channel where it's just you, me, and math. I'm Jody, and today we're going to be talking about Sohcahtoa. Now, on my last video, which I'll link up here, I talked about the Pythagorean Theorem, which dealt with side lengths of right triangles, but today we're going to throw angles into the mix. So without further ado, let's get into it. First of all, Sohcahtoa. That sounds like it's not a word, and that's because it's not. It's abbreviations for trigonometric equations or trigonometric ratios. You'll often see it written like this, Sohcahtoa, in one long version here, but what you want to realize is that there are actually three separate equations, So, Ka, and Toa. So they're abbreviated right here, but I've written them out more thoroughly right here. So first of all, let's talk about what everything stands for. So the hypotenuse, as I talked about in my Pythagorean Theorem video, is the side that's across from the right angle. So the right angle is here, that's going to be your hypotenuse. Now, opposite and adjacent, that really depends on what angle you're talking about, because what's important to know is that it's opposite to the angle you're talking about, and adjacent is adjacent to or next to the angle you're talking about. So if we imagine this as a triangular shaped room right here, and you're standing in theta's corner, the wall of the room opposite to you would be this one over here. But if you were standing in phi or phi's corner, however you pronounce it, then opposite wall would be over here. So it depends where you're at. So that's why it says side opposite your angle, side adjacent to your angle. So that's what's really important. Now let's talk about how this turns into these trigonometric ratio equations. So sine is usually abbreviated with sin, but don't pronounce it as sin because it's representing sine of an angle. Cosine is abbreviated COS and tangent TAN, but again, don't say cos and tan. Be thorough and say the whole word, but we don't want to have to write it every time. Therefore, we just abbreviate. So the sine of any angle, which is theta or phi, or you could label them with letters, it really doesn't matter. I guess those are letters, they're Greek letters, but I mean like English letters if you want to, or you could label it with a tree. It doesn't matter. But the sine of any angle is equal to the ratio of the opposite wall from that angle divided by the hypotenuse. Cosine is adjacent over hypotenuse and tangent is opposite over adjacent. So the one that's a staple throughout the whole triangle is this is the hypotenuse, no matter where you're standing, quote unquote. However, again, if you're in theta's corner, adjacent would be next to you right here. But if you're in this corner, adjacent would be next to you right here. So let's do some examples so that you can see that more in depth. We're going to use this triangle to solve these problems here. So I kind of wrote up just the abbreviations over here. Now, just to describe this right triangle, and also, I don't know if I said before, but if I didn't, Sohcahtoa is only applicable on right triangles, just like the Pythagorean Theorem is only applicable on right triangles. So definitely good to know. I'll do non-right triangles in another video. That's future me's problem. Okay. Now, x, y, and z are representing these side lengths. So let's talk about sine of theta. So again, what you want to realize is theta is the corner of the room that you're standing in. So you can say, okay, I'm standing in theta's corner. Very artistic here. So sine is opposite over hypotenuse. So I'd recommend writing the letters every single time until you get it memorized. So we're going to go sine is opposite over hypotenuse. Now let's actually find the letters. So from theta's corner, the wall opposite you is going to be y. And then the hypotenuse is going to be z. So the answer to this would be y over z. And that's it. So sine, cosine, and tangent are just ratios. They're just dividing two sides, and you just have to figure out which sides. Cosine of theta, again, we're going to be standing in theta's corner. So always pay attention to which angle is mentioned, because notice over here I've mentioned the other one. So cosine is a over h. Now, how do you memorize those other than the fact that it sounds like Sohcahtoa? There's lots of different stories and things like that, but if you just think that it is what it sounds like, for example, so, you got to try to say the H, ka, and then toa, that one kind of flows, then hopefully that'll be easier to remember. But the more you write them out and the more you write the letters, the easier it is to remember, and the quicker you will learn to remember them. Wow, the English. Anyway, so when you are right here in theta's corner, the wall adjacent to you, so the one that you can reach out and touch that isn't the hypotenuse, because again, this is the hypotenuse, would be x. So this would be x over z. So this is the hypotenuse no matter where you're standing. So that one's always labeled like set in stone. You can put that there and just know you're good. But the other two depend on where you're standing. So let's do this one, tangent of theta. So we're standing in theta's corner. So we're going to go, all right, toa opposite over adjacent, so opposite wall y over adjacent wall x. So it's y over x and that's it. So once you get in your mind the O and A are opposite and adjacent to your angle, then these become a lot easier. So let's talk about these ones. Now in all three of these ratios or equations here, we're standing in phi's corner. So we're going to say, all right, if I'm standing here in this weird triangular shaped room, if I'm standing up here, the wall that's opposite me would be the x. So we're still going to say it's opposite over hypotenuse, but the opposite is x and the hypotenuse is z. So your entire answer would be x over z. How about cosine? Adjacent over hypotenuse. So when we're here, the wall adjacent is y. So it'd be y over z. Last one, tangent, toa. Sohcahtoa. So toa would be opposite from phi, so phi or phi. I flip-flop between the pronunciations because I've heard it pronounced both ways, so excuse me if I do it both ways. So tangent from here is opposite x over adjacent y. So that was an example just using letters, but let's do another one next where I throw numbers into the mix and see how that works out. All right, so again, I have used theta and phi, or phi, and I turned the triangle. You just need to know it doesn't matter how the triangle is oriented visually. You just have to make sure that across from your right angle, that's the hypotenuse. So we can label that one because he's always set in stone. The other two depend where you're standing. And where you're standing is going to be whatever is mentioned right here. So let's start with sine of theta. So you're standing in theta's corner here. All right, so sine is so opposite over hypotenuse. And from theta, the wall opposite you would be 5. Opposite is always the wall that's furthest away from the angle. So that would be 5 over the hypotenuse is 13. Let's talk about cosine of phi now. So notice the angle has changed, so you've moved in the room. You're standing over here. Cosine is adjacent over hypotenuse, so ca. So adjacent to phi would be 5, and then the hypotenuse of the triangle is 13, so that is the answer there. Now notice those are the same. That's okay, but notice they were different original problems. It just depends where you're at, and you can get same answers from different problems. All right, now tangent of phi, let's try that one. So tangent would be opposite. Oh, we don't know that wall. However, we can find it, and we have to find it. So to find the third wall, or the third side of any right triangle, we just employ the Pythagorean Theorem. Yay! So Pythagorean Theorem and Sohcahtoa come hand in hand all the time. Very, very, very common. So we're going to set that up. So this is going to be A, B, and C. So we're going to go 5 squared plus, let's just call this one B. B squared equals 13 squared. So let me solve that out really quick and we'll know how long that is and then we can proceed with the problem. B is 12. So now we can actually finish the rest of these because we know all 3 sides. Now we could have started with that, but sometimes you don't realize you might need to. So tangent of phi, tangent would be opposite, 12 over adjacent, 5. So O over A, 12 over 5. Okay, now again, tangent, but it's from theta. So from theta, opposite would be 5, adjacent would be 12. And then cosine and sine down here. Cosine of theta, so ca, would be 12 over 13. And sine is so, does that get old? Has it gotten old? Probably. So sine of phi is going to be opposite over hypotenuse, so that would be 12 over 13. All right. Let me know what questions you have about all of that down below in the comments, or let me know if this is helping in your understanding a lot better. So what I'm going to do next is write up a practice triangle for you, and I'll have you pause it and then try it all, and then we'll come back together and have a meeting of the minds and make sure that our answers are all the same and that you're understanding. So let me do that really quick. I'll be right back. Here is what I would like you to try. Notice I labeled angles with A, B, and C this time, and that's fine. You'll see a lot of variation in that, so I wanted to switch it up a little. So pause the video, pause it, and write them all out, because that's the best way you'll know what questions you have, if any. Hopefully it makes sense. And I'll pause the video as well, and then I'll write up all the answers, and then we'll meet back up and make sure that they're all good. So ready, set, go. How did we do? Did you try it on your own? Let me know. So make sure that you know that you should reduce all of your fractions. That's always true just in math in general. So make sure that you do that. Now I wrote over here how to find the hypotenuse, which is going to be 10. So look over these. Let me know if you have questions. Thank you so much for joining me. I would like to do a couple more Sohcahtoa videos as well, because notice I didn't do anything where I asked you to actually find the angles, but that is something that's important to know as well. So let me know if you'd like to see more. But thank you so much for coming. I hope you will subscribe and like the video, and I can't wait to see you guys next time. Have a beautiful day wherever you are.